Feedback amplifier. Feedback is the process of taking a portion of an amplifier's output signal and feeding it back into the input. There are two kinds of feedback, positive feedback and negative feedback. In positive feedback, the feedback energy, either voltage or current, is in phase with the input signal and thus it aids the input signal. Negative feedback, the feedback energy is out of phase with the input signal and thus opposes the input signal. This is the block diagram of a positive feedback. This input signal, output signal, and this is the feedback. The input signal is passed through an amplifier which provides a phase shift of 180 degree. Therefore, the input signal and output signal have a phase shift of 180 degree. A portion of the output is feedback to the input through the feedback network. The feedback network provides a further phase shift of 180 degree. Thus, the input and the feedback signal are in phase. Thus, the feedback voltage aids the input signal. But in negative feedback, the feedback network does not provide any phase shift. Thus, the feedback energy and input signal are out of phase with a phase shift of 180 degree. Thus, the feedback energy opposes the input signal. The input signal and feedback signal are in phase in positive feedback, but in negative feedback, the input signal and feedback signal are out of phase by 180 degree. Voltage gain of positive feedback network is A by 1 minus beta A, and that of negative feedback is A by 1 plus beta A. The stability of amplifier decreases in positive feedback, but the stability of amplifier increases in negative feedback. Positive feedback increases distortion, negative feedback reduces distortion. Bandwidth decreases in positive feedback and bandwidth increases in negative feedback. Positive feedback is used in oscillators, but negative feedback is used in amplifiers. Now we are focusing more on negative feedback. Negative feedback returns part of the output to oppose the input, whereas in positive feedback, the feedback signal aids the input signal. This is a feedback amplifier with feedback fraction beta, feedback voltage Vf. Vs is the input signal and Vo is the output signal. If Vf equal to 0, there is no feedback. Therefore, gain is equal to Vo by Vs, that is equal to Vo by Vi. If feedback signal Vf is connected in series with the input, then Vi is equal to Vs minus Vf, since it is negative feedback. Vo is equal to A into Vi, that's equal to A into Vs minus Vf. But Vf is equal to beta times Vo. Therefore, Vo is equal to A into Vs minus beta Vo, or Vo into 1 plus beta A is equal to A into Vs. Vo by Vs is equal to AF, that's equal to A by 1 plus beta A, where A is the open loop gain of the amplifier and AF is the closed loop gain of the amplifier, or gain of the amplifier with the feedback. Advantages of negative feedback. For negative feedback, beta A is greater than 0, and for positive feedback, beta A is less than 0. Reduction in frequency distortion. For a negative feedback amplifier, beta A is normally very much greater than 1. We know AF is equal to A by 1 plus beta A. Since beta A is very much greater than 1, 1 plus beta A is approximately equal to beta A. Therefore, AF is approximately equal to 1 by beta. If the feedback network is purely resistive, the gain with the feedback is independent on frequency. Thus, the frequency distortion reduces in negative feedback. Gain stability. We have AF is equal to A by 1 plus beta A. Taking differential, DAF is equal to DA by 1 plus beta A all square. DAF by AF is equal to 1 by 1 plus beta A dA by A. That means the magnitude of relative change in gain of AF, that is DAF by AF, is reduced by a factor of 1 plus beta A compared to that without feedback, that is dA by A. Thus, gain stability increases with the negative feedback. Reduction of nonlinear distortion. Nonlinear distortion df is equal to d by 1 plus beta a. df is the distortion with feedback. Distortion is reduced by a factor of 1 plus beta a with a negative feedback. These are the two curves. This one is the open loop gain and this is the closed loop gain. This is more or less linear. Thus, there is nonlinear distortion reduction in negative feedback. Bandwidth extension. Here A is without feedback and this is with the feedback. With the feedback, bandwidth is 2f minus 1f, which is bigger than f2 minus f1. Thus, amplifier with negative feedback has more bandwidth than without feedback.